Okay, good afternoon, everyone. Okay, so my name is Yue Huan, and today I want to share some experience about the Orange Software Community Release E, and they implement the Near-RT RIC platform. So today we want to share this experience. Okay, so this is today's outline. First, I will just briefly introduce the Near-RT RIC. Then I will show the architecture the OSC implements. Then I will show each component in the Near-RT RIC platform, and I will briefly introduce. And I will show the infrastructure. How does OSC run these components? And I will show the results we deploy this RIC platform on our servers. Then I will show the appendix about the command, and at the end is the QA. So the first is the introduction. So what is the Near-RT RIC platform? Okay, I think previous sections Winnie has shown very detailed about the Near-RT RIC platform. So actually Near-RT RIC platform is here. This figure is defined by Orange Alliance, and actually, as you can see, there are three interfaces: E2, A1, O1. E2 connected to E2 node. Actually, E2 node would be the base stations, and the base station supports the E2 connection. And the A1 and O1, it will connect it to SNO, and A1 will connect it to the non-RT RIC. So actually, we can see the Near-RT RIC platform as here, as this figure. So actually, OSC just divide Near-RT RIC platform, Near-RT RIC into the Near-RT RIC platform and xApp. So why does OSC want to do this? I think the reason is they want to simplify the complexity of the xApp development. So it just want to provide a platform and lets each xApp running on top of this platform. So this platform would have these functions, something like message infrastructure, database, and the E2, A1, O1 connection. Okay, so actually, the xApp is we want to put some algorithm. This algorithm would optimize, or we just want to control this base station, this E2 node. So we just put this algorithm here in the xApp. So xApp can run on top of the platform. So we will just focus on the Near-RT RIC platform and how does OSC implement the functions defined by Orange. Okay. Okay, let's see the architecture. Okay, so actually OSC implement this Near-RT RIC platform with several components. So you can see this figure, there are several components. So on your left-hand side is the functions provided by this OSC Near-RT RIC platform. So the first one is is very important. Is message infrastructure. We can map into this is the routing manager. And the second is the data access. You just store access the database. Then there are three interfaces connected to a Near-RT RIC platform. So we need some components to handle this interface connection. Okay, so next is the subscription manager. So actually, it was also an important function defined by Orange. So we just we need to isolate this as a component to handle the substitution. Okay, so next is the alliances occur or some faults or some metrics. We need to report this data to the higher layer, something like SNO over the O1 interface. Okay, so the next, the last one is the xApp lifecycle management. Okay, so it's a very important functions because we want to let xApp run on top of this platform. Okay, so let me introduce each component. First, I want to introduce is a library, but it's very important because this library is called RIC Message Router. The abbreviation we call it is RMR. So actually, IR is a peer-to-peer library distributed in each platform component and xApp. The goal is to let different components in this platform to communicate. So actually, if you want to communicate, you need a routing table because you need to find the right person or right components to communicate with him. Okay, so actually it provides two methods to provide a routing table. First is dynamic, but the dynamic it will need the other components in the RIC platform to support this. I just want to show the static routing table here. Okay, so as you can see this figure, there are two xApp A and B. So how does xApp A connect to xApp B? Okay, we just use a local routing table. So we just need to write a routing table and put to this xApp. So xApp can know, oh, if I want to transmit to if I want to transmit a message, and with this message type would be 30,000. And how can I communicate to? I will use xApp domain name, then its ports, so I can directly correctly send to xApp. Okay. So next is the routing manager. Routing manager is a routing center in the Near-RT platform. So it represents the message infrastructure defined by ORAN. So it just provides parts of the functions. So this routing manager can let each component in platform create and update their routing table. So when each component just in runtime in this Near-RT platform, so maybe they will communicate to routing manager to update their routing table. As you can see, there's a xApp, but we know actually we just focus on the Near-RT platform, but how does xApp actually run on top of the Near-RT platform? Actually, it will use another function. I will just introduce this later. So actually, we need some mechanism to communicate with routing manager. So actually, it will define by RIC Message Router this library because these components they want to use the RIC Message Router to communicate to each other, so they need this. So after routing manager knows they need to update the routing path, so it will distribute the updated routing path to each component. So they can communicate to each other according to this updated routing path. So actually, the dynamic routing table can also be used in runtime. Okay, so next is the Redis database. Okay, so Redis database is just to store the data. So actually, already defined an API is the shared data layer API. So each component, if they want to communicate, if they want to access the database, so SDL shared data layer provide a good way, a simple way to establish the connection between the components and Redis, and they can just access the database easier. Okay, so for example, E2 Manager may use shared data layer API to access the E2 Manager database. Okay, so next is the E2 termination. So as you can see, there is a E2 interface defined by ORAN, right? So how does this E2 interface work? Actually, ORAN define this E2 interface with this protocol stack. So actually, when E2 node want to communicate with the RIC, actually you need to use the E2 AP this specification. So actually E2 AP would on top of the HTTP. So actually E2 termination need to establish with E2 node for the HTTP connection first. Then they can transmit use the E2 AP protocol to communicate with this Near-RT RIC platform. Okay, so actually E2 termination would be important for the E2 interface because it will be a terminations in Near-RT RIC for E2. And each component, other components in Near-RT RIC platform may use a RIC Message Router to communicate with E2 termination to forward E2 message. So we call this E2 message communication with into the E2 procedures. So this is a very important part in about related to E2 interface. So next is the E2 Manager. So E2 Manager is mainly used to identify the E2 node because you want to establish the E2 connections with platform and E2 nodes. Okay, so the reasons why does they want to identify? Because if the Near-RT RIC if the Near-RT RIC platform or the xApp want to communicate with the E2 node, we need to know who is E2 node, and we need to find out a routing path or a communication path to send a message to the correct or the right E2 node. Okay, so actually the first function is to identify the E2 node. So when the E2 node want to communicate with the E2 with the Near-RT RIC platform, it will E2 termination would receive this request and it will forward to E2 manager. So E2 manager would identify this message. So if E2 manager decide to accept this connection, this connection, so it will ask routing manager to create a routing path for communicates with the E2node. So we just took this before. It's a dynamic routing path update. Then actually you will also store the E2node information. You will store some information, something like the functions this E2node supposed to be controlled. So actually, xApp can reuse this mechanism to know, oh, this E2node supports what kind of function, so I can control it or not. Okay. Next is the subscription manager. Actually, subscription manager is to manage the subscription. Yes. So actually, xApp would send the subscription request, and you want to ask the E2node to be subscribed. So xApp need to send this message to subscription manager, because if you want to manage the subscription, then subscription manager can forward this message and identify this message, then forward to termination to go the further procedure. So actually, if we want to communicate with this E2node, if this xApp want to communicate with this E2node, it also need to create this routing table, this routing path for the communication between the xApp and this E2node. So this routing manager, so subscription manager may trigger the routing table update. Okay, so next is related to the xApp. It's the xApp manager. Okay, xApp manager is to let a platform component to know the xApp. So actually, if we want to run this xApp in the Near-RT RIC platform, we need to let the platform know who is the xApp and what kind of functions this xApp needed to use. Okay, so actually there is registration procedures, and there's a lifecycle management procedures for these measurements. So actually, xApp may use the registration to xApp manager. Then you will tell the routing manager, oh, this xApp want to support some message and you want to communicate with who. Then you will update the routing table. Also, xApp manager would tell the VSPA manager to talk about the metrics it supports to provide some metric to the higher layer. Okay. So next is the A1 mediate. Okay. So actually, this A1 mediate is related to the A1 interface. Actually, A1 interface defines 3 functions, but actually, in OSC Near-RT RIC Platform, currently they only support the A1 AP and they just support A1 policy and A1 enrichment information to provide extra informations to Near-RT RIC Platform. So actually, A1 mediator is just a mediator between the xApp and non-RT RIC. So A1 mediator just to recall the policy the non-RT RIC ask the provide to xApp. So it just forward to xApp. So this protocol stack is defined by the ORAN. They just use the RESTful API to define these communications. Okay, so next is the alert system. Okay, so alert system is to collect alert message from different components and also collect the metrics from different components and then forward to the higher layer. Higher layer is the SNO over the OI interface. So the first function it provides is the fault management, because if layer is wrong, if layer is wrong, so they will raise some a warning message or error message, and it need to be collect, and it need to be forward, it need to be transmitted to the higher layer. So the person from the higher layer can know what event, which event, what kind of events the Yeti RIC is occur. So actually, it will use this alert manager to receive the message, then forward to alert manager to transfer the format, and then forward to VSPA. Then VSPA can communicate with the service model orchestrations. Okay. Okay, so this introduction above is about the components introductions. So next, I will introduce our infrastructure. Okay, so actually, open software community use this infrastructure to deploy their components. So they just run as a Docker container, as the Kubernetes part, and it just use the hand to management. So actually, they just write the hand charts to, this hand chart would include some namespace, some basic informations, some namespace, some button about the config, service about the ports, or the domain, or the deployment about the basic informations. So this hand can apply, and it will ask Kubernetes to create this resource. Then this resource will map to this Docker container to management this Docker container. So okay, so if you are interested in this part, or if you are interested in Near-RT RIC platforms, I think this infrastructure is it's good to be learned. It will be better for you to debug or to develop other things. Okay, thank you. Okay, so let's see the results. So actually, we just deploy our Near-RT RIC platform on the server, a bare metal. So we just without the virtual machine. So we just use the group control command to get all the running pod, and with the namespace we can see. Okay, so this is the running application, and actually you can see there are some different, there are some optional components provided here. So which means it's not necessary for this Near-RT RIC platform. But if you want to achieve other functions or other goal, maybe you can also deploy or develop your applications. And also there's a API gateway for communicate with some applications in the Near-RT RIC platform. Okay, this is the appendix. So I just list some. I think I just list some comments. I think this will be useful when you develop or just to debug. It will be useful. So maybe you can try to find it out. Okay. Okay. So it's a Q&A time. So if you have any questions, you can raise here.
不好意思，就是我再请教一个问题啊，就是在 ORIC 里面有定义出很多的 interface， 那这些 interface 的简写它有没有一个关联性？我看起来好像都没有什么太大的 关联，像是 A1 啦、E1、E2、F1 这样子。因为我有试着查过相关的讯息，好像没有太多的说明。
OK，您的问题是关于一些 interface ORAN 定义的问题嘛？那其实我这边也没有什么就是太多的了解，因为我也有去查过就是相关的东西，但其实没有什么有关的。但是我只知道在 CUCP 跟 CUP 那边会用 E1，那这边是用 E2，那 A1 你可以把它想成 artificial，就是它比较它可能是比较智慧一点吧。然后 O1 可能是指 management 的 part，对你可能这部分可能就是要自己去呃记起它嘛，还是背起它这样子。OK，所以我这没有办法提供就是相关的资讯。
哦，谢谢谢谢。
不会不会。
I have a question.
OK，
Oh. So can I ask?
yes.
Yeah, so I have a question regarding routing manager. What kind of components it contains? Like,
Sorry, you means the routing manager, right?
the slide with, yeah, no, routing manager. Yeah.
Okay. This one?
No, yeah, this one.
Okay. So your question is,
So what is the purpose of routing manager to route between which components?
okay.
Like,
Actually, if actually Near-RT RIC Platform, actually routing manager is just to it's just to create the routing path. So why we want to create the routing path? Because we may deploy the xApp when this component is in the runtime, or we just added additional components on
oh,
top
I
list.
see.
Okay.
So it contains like the list of xApps, right?
Contents. Oh no. Actually, it's just to provide these components, the routing path.
Oh, okay.
Yes. Oh, this direction line is just to indicate this routing manager would provide these components, the routing table, the updated routing table. Okay.
I see.
Okay.
Okay.
And Anna's question is, do you have example for row table?
Yeah, that would be very useful.
Okay. If there are any questions?
No, Yuan. Anna want to know, do you have a example for routing table?
Oh, yes.
Yeah.
Sorry, wait 1 second. Let me change it. Okay. So I just show a simple example here. It just the format is just look like this. It will begin with the route. RT it will mean the route. Then it will have a message
I
type.
see.
Okay.
Yeah. Okay.
Okay, thank you. It's a good question.
Hi, everyone. Sorry,
Hi, Bimo.
I want to confirm. So the purpose of the routing manager is having access for all the xApps that deployed and also keep updating the local routing table. Is it correct?
Yes, yes, correct.
Okay.
Any other question? No, if you don't have a question, maybe we can end the session now.
Okay, thank you.
Okay. Thank you.